The air is thick with smoke, swirling and curling around ancient beams, carrying the scent of burning coal and hot metal. Every breath is heavy, filled with the memory of centuries past, as if the very walls are steeped in the stories of those who came before. And then, the unmistakable clang of hammer on steel rings out, a sound that echoes through time, resonating with the same force it did 1,000 years ago. Each strike is a heartbeat, a rhythm that has shaped civilizations. Sparks fly in every direction, illuminating a face etched with sweat, grit, and unwavering focus. The blacksmith's eyes reflect the fire, revealing a deep connection to the craft, a silent conversation between human and metal. This isn't just a workshop, it's a crucible where history is forged and legends are born. For millennia, blacksmiths have transformed raw earth into objects of power and beauty. They poured not just knowledge, but their very spirit and dreams into every blade, every tool, every artifact. Imagine, no blueprints, no laboratories, no modern machines, just intuition, experience, and the relentless heat of the forge. Swords so sharp they inspired myth, so strong they shaped the fate of empires and the course of history itself. These stories might sound like fantasy, but they're grounded in real science. The secrets of strength and sharpness were hidden deep within the steel, waiting for the right hands and minds to unlock them. Each blade was a puzzle, solved through trial, error, and innovation. From the bustling markets of the Middle East to the misty mountains of Japan, this legacy surrounds us. Excalibur, Damascus, Katana, each one a masterpiece of ancient engineering, each with its own story, its own secrets, its own place in the tapestry of human achievement. These smiths were true pioneers, constantly pushing the limits of their materials and their own abilities. Their quest for the perfect blade was not just a job, it was a lifelong pursuit, a calling that demanded patience, skill, and relentless curiosity. Today, we step into the forge to uncover the science behind the legend. This is more than a story. It's a journey into the heart of ancient innovation, where every spark tells a tale. The anvil is waiting. Let's begin. Our journey begins in the bustling heart of ancient Damascus, a city where the worlds of legend and metallurgy collided in spectacular fashion. Here, in the shadowy corners of crowded marketplaces, skilled blacksmiths worked their forges, shaping metal into objects of both beauty and power. When crusaders returned from the east, they brought with them astonishing tales of swords that shimmered with mysterious watery patterns, blades that would come to be known as Damascus Steel. These weapons were unlike anything seen in Europe, captivating warriors and collectors alike. Renowned for their extraordinary sharpness and resilience, Damascus swords could slice through armor and retain their edge through countless battles. Yet what truly set them apart was the mesmerizing, rippling pattern that danced across their surface, hinting at secrets hidden within the steel itself. This intricate design, known as the jauhar, was far more than mere decoration. It was a symbol of superior craftsmanship and a mark of authenticity, signifying that the blade was forged by a true master. For centuries, the exact method for creating genuine Damascus steel was shrouded in mystery. The recipe, passed down through generations, eventually vanished, leaving only legends and imitations behind. The secret ingredient behind these legendary blades was Wootz steel, imported from the distant lands of India. This unique material, now lost to history, was the foundation upon which Damascus steel's reputation was built. European blacksmiths, fascinated by the beauty and performance of Damascus blades, tried to replicate their appearance. However, while they could mimic the look, they could never quite match the remarkable properties of the originals. The true secret lay in the steel's chemistry, a precise high-carbon mix that had been perfected over countless generations. This delicate balance gave Damascus steel its legendary strength and flexibility. The answer to the mystery of Damascus steel wasn't hidden in ancient scrolls or lost recipes, but rather at a microscopic scale, invisible to the naked eye and only recently revealed by science. With the advent of modern technology, scientists could finally peer deep into the structure of these blades, uncovering the secrets that had eluded generations of smiths and scholars. What they discovered was astonishing. The secret of Damascus steel lay in its nanostructure, a world so small it borders on the realm of science fiction. The story of these legendary blades would ultimately lead us into the fascinating world of nanotechnology. Let's look even closer. The mystery of Damascus steel endured for centuries. Then, German researchers used electron microscopes to examine a 17th century Damascus blade. What they found was astonishing. Carbon nanotubes, one of the strongest materials known, embedded in ancient steel. The wood steel's unique impurities, like vanadium, acted as catalysts, forming these nanostructures during forging. They also found nanowires of cementite, creating the blade's visible pattern. The forging process aligned these nanowires, while the nanotubes reinforced the steel, much like rebar in concrete. The result? A blade with a razor edge and remarkable toughness. Ancient smiths, through intuition, created a high-performance nanocomposite centuries before modern science. They were nanotechnology pioneers, without ever knowing it. The Damascus blade was a marvel of both art and accidental science. The secret was in the structure, not just the story. Now let us journey to Japan, the birthplace of the legendary katana. A blade revered not just for its cutting power, but for the spirit and tradition infused into every inch of steel. The katana is more than a weapon. It is a symbol of the samurai's soul, a fusion of artistry, discipline, and centuries-old wisdom. Japanese swordsmiths began with a daunting challenge. The iron sand found in their homeland was impure and difficult to work with. Yet, it was this very challenge that sparked their ingenuity, leading to a process of purification that would become legendary. In clay furnaces known as tatara, teams of smiths worked tirelessly, smelting iron sand and charcoal together for up to 3 days and nights. The intense heat and careful tending produced a spongy mass of steel called kira, a bloom that held both promise and imperfection. From this bloom, the smiths would painstakingly select the purest, brightest fragments, tamahagen. These rare pieces, chosen for their quality, would become the very heart and soul of the katana. The forging process began with folding, heating, hammering, and doubling the steel over itself, sometimes more than 15 times. Each fold was a test of patience and skill, as the smith worked to transform raw material into something extraordinary. With every fold, impurities were driven out, and the carbon content was evenly distributed. This created thousands of microscopic layers, each one contributing to the blade's strength and beauty. The result was a blade with a unique microstructure, strong yet flexible. This intricate layering allowed the katana to withstand powerful blows without breaking, while maintaining a razor-sharp edge. But the smiths didn't stop there. They combined hard, high-carbon steel for the cutting edge with softer, more resilient steel for the spine, forging a composite blade that balanced sharpness with durability. The finished blade was an engineering marvel, strong, sharp, and resilient, capable of slicing through armor and bamboo alike. Yet the katana's true magic was still to come. The most critical transformation was about to begin. The blade was heated to a glowing red, then plunged into water in a dramatic fiery baptism. This rapid cooling, or quenching, locked in the blade's hardness and created the katana's signature curve. The katana emerged not just as a weapon, but as a masterpiece of material science and craftsmanship. Each one unique, each one a testament to the smith's skill. But the journey wasn't over. The edge had to be perfected, honed to a mirror finish with whetstones, a process that could take days of careful work. The final touch was the hamen, the wavy line along the blade, a visible mark of the tempering process and a symbol of the katana's spirit. This is where the true artistry of the swordsmith shines. The katana's wavy hamen isn't just decoration, it's proof of differential hardening. Before quenching, smiths coated the blade in clay, scraping it thin at the edge and thick on the spine. Heated and plunged into water, the edge cooled instantly, forming glass-hard martensite, while the spine stayed flexible. The hamen marks the boundary between hard and soft steel. This gave the katana a razor edge and a shock-absorbing spine, solving the age-old dilemma of hardness versus toughness. Each blade was unique, its hamen a signature of the smith. The Japanese masters engineered a blade with the best of both worlds. The katana became the ultimate cutting weapon. Folding steel wasn't just purification, it was structural engineering. Like a phone book resists tearing, thousands of steel layers made the katana resilient. Each fold distributed force and stopped cracks from spreading. The process homogenized the steel, squeezing out impurities and evening carbon content. The result? A reliable, tough blade from flawed raw material. The folding also created the hada, a wood grain pattern unique to each blade. The hada revealed the smith's skill in school, a fingerprint of the forging process. While other cultures folded steel, Japan perfected it for both beauty and strength. They turned material limitations into innovation. The katana's structure was as complex as its legend. Modern steel is made in massive, precise mills, uniform, reliable, and perfect for skyscrapers. Ancient smelting was an art of intuition, not science. Smiths relied on the color of flames and the sound of the furnace, not sensors. Each batch of steel was unique, shaped by its raw materials and the smith's skill. Modern engineers see inconsistency as a flaw. Ancient smiths saw it as character. They developed folding and hardening techniques to turn unpredictability into strength. The goal wasn't mass production, but a single perfect masterpiece. Modern steel is superior for industry, but ancient blades have unique properties. The microstructures in Damascus and Katana steel are hard to replicate today. Ancient smiths were hands-on material scientists, their forges true laboratories. Their legacy is innovation born from imperfection. Beyond metallurgy, the human factor set these blades apart. Apprentices spent years learning by watching, absorbing every detail. Forging a katana took months of relentless, careful work. One mistake could mean starting over from scratch. Rituals and spiritual intent infused every step, making the forge a sacred space. The smith aimed to create not just a weapon, but a vessel for spirit and perfection. This dedication and patience are impossible to automate. The true secret ingredient was the devotion of the maker. We often underestimate ancient ingenuity. Damascus Steel and the katana prove that genius isn't new. These masters were material scientists, running experiments and refining techniques. Their work is a library of forgotten knowledge, waiting to be rediscovered. By studying their methods, we can unlock new ideas for the future. What other secrets lie in ancient artifacts? Let's rebuild, recreate, and learn, not just for museums, but for innovation. Fusing ancient intuition with modern science could spark a new materials revolution. The forge is lit again. The echoes of old hammers call us. The past is a blueprint for the future. The next breakthrough may come from lessons learned in ancient fire. The secrets of the old masters aren't lost. They're waiting for us.